about rationalizing the denominator. So when we talk about rationalizing the denominator, we're simply talking about removing removing the radical on the denominator. So rationalizing the denominator is all about removing the radical on the denominator. So we also know that the radical, it's also called a square root. So I'll just use this to represent a square root or to refer to a square root. That's how we normally call it. So this rationalizing the denominator in other words, it's eliminating the square root on the denominator, um on the denominator denominator. So it's very important to understand the goal, right, of what you're doing when you're approaching a certain problem. So whenever they say rationalize, the goal for that question will be for you to remove the square root or the radical on the denominator. So before you get into it, you need to understand was it the different types of radicals that are there that you need to sort of like know, so that you can be able to solve, right? So I'll just keep this simple. The a radical, it's it's whenever you have a square root of like maybe x, right? This is a radical, and also this radical, it's also equals to 2 root of x, and then this is also represented as x to the power 1 over 2, right? That's a basic radical that you will encounter. Another way of representing a radical, it could be n root of x to the m, right? In this case, that means you have a radical that can also be represented like this: root of n x and then close bracket to the m, and then this is also the same as x to the m over n, right? So you need to understand the radicals, the different types of radicals, before you can actually get to solve or get to answer question on how to rationalize, right? So for purposes just to get the understanding cleared up, let's take a simple problem just to do a simple problem. Example one, let's say you have 2 over root of 5, and then they say rationalize, right? You are required to rationalize. So in order to rationalize this problem, we need to multiply by a convenient form of 1. So we multiply by a convenient form of 1. So in this case, what is a convenient form of 1 that we can multiply by in order for us to solve the following, or in order to rationalize the following problem, or to remove the radical on the denominator? So in this case, we're going to multiply by root of 5 over root of 5, right? We know that root of 5 divided by root of 5 is just 1, and anything multiplied by 1, it's that thing. So in this case, the reason why we're multiplying this by root of 5, we know that in the denominator, we're going to have root of 5 multiplied by root of 5, which is just 5, right? That's what we know, because this comes from a law that says root of a multiplied by root of a, it's equals to a. It's always given. Like whenever you multiply the same type of square root together, you will get whatever is inside the square root. So how you would structure solving this problem, it's gonna become 2 root of 5. So, and then this is just root of 5. I just like rewriting it down again to show that the direct multiplication, this 2 times this, and then root of 5 times 5. So that's sort of like your direct multiplication in there. So this you don't worry much about the top part. You focus mainly on the denominator because that's what we're doing. So in this case, what happens here, this is just 5. One way to look at this, you already know that was it you already know that root of 5 multiplied by root of 5 could also give you 5 to the power 1 over 2 multiplied by 5 to the power 1 over 2, which is what happens when it's like this same basis, we add the exponents because they are multiplied together. So this is 5 to the power 1 over 2, 1 over 2 plus 1 over 2, and we know that 1 over 2 plus 1 over 2 is just 1, which is just 5. And then in this case we have rationalized the denominator. So this is one way or another to just how you can actually see this. Also, this this we can just maybe do another example so that you can actually get to see more of this or how it works. And then let's say you're given 8 over 4 root of 4x, right? And then this now, when what is the convenient form of 1 that we can use in this case, it will be 8 over 4x. The convenient form of 1 in this case will be root of everything inside the square root. You take it as it is, right? 4x. Everything inside the square root, you take it as it is. And then this simply becomes 8 root of 4x over, what is root of 4x multiplied by root of 4x? It's just 4x, right? It's just 4x. And then let's say we require to simplify it to the simplest form. This would just become 8 root of 4 root of x over 4x, right? And then this becomes, what is this? This is 8 multiplied by 2 multiplied by root of x, right, over 4x. Then you will see that this, what is this? This is 16 root of x over 4x. Then this simply becomes just root of, was it 4x, was it 4 root of x over x. So that's the simplest form for this problem. Yeah, just moving right along just to get another example done that maybe you might find it a bit more interesting, or let's just involve something that includes the conjugate, right? Includes the conjugate. So let's say we have 5. This is our example 3, by the way. Example 3. Let's say we have 5 over 4 minus root of 2, right? In this case, what are we going to do? We're going to multiply by the conjugate. And then to multiply by the conjugate, that means we will have 5. This is equals to 5, 4 minus root of 2. And then in this case, our conjugate is just simply changing the sign. So this is 4 plus root of 2 over 4 plus root of 2. And then this is the conjugate. Whenever we talk about the conjugate, we're talking about changing the sign in between, right? So you copy whatever is in the denominator as it is, but you change the sign. And then you will see the importance of that. So let's multiply. This results in 5, 4 plus root of 2. And then in the denominator, we're going to have 4 minus root of 2, then 4 plus root of 2, right? So in this case, when it's like this, we need to distribute it in the denominator. So let's just have it here. So this is 5, 4 plus root of 2. We leave whatever is in the denominator like that, and then let's deal with this. So we're going to distribute, what is this times this? 4 times 4, and then it would give us 16, right? It would give us 16. And then what is 4 times root of 2? It's going to become plus 4 root of 2. And then what is so this is times this is what I'm multiplying. And then yeah, you just need to know how to actually get to do this. So this is minus 4 root of 2. And then what is root of 2 times root of 2? This will be minus 2. Right. And then one thing you'll note is that always, whenever you multiply by the conjugate, these two terms will always cancel out. So these two terms will always cancel out. Let's just cancel like that. Then the final answer for this problem just becomes 5, 4 plus root of 2 over, what is 16 minus 2? 16 minus 2 is just 14. So you could actually leave it like this. This will be your final answer. Thank you for watching the video. Do not forget to like, subscribe, and click the notification button for future uploads.